Two DVB ASI transport streams, frequency corrected to a common clock. Are we ready to switch yet? Not yet. Not quite. Remember, these are MPEG transport streams. We can't switch at some arbitrary point in one stream into the other. So the 4445 ASI Clean Switch is going to look at the structure of the transport stream. It's going to look for iframes and align them to each other. That mechanism is an essential part of the whole process. In order to do that, there are memory buffers, both in the primary and in the secondary path. Those memory buffers allow us to shift the timing of one stream with respect to the other. Through the control system, you can target the point in the stream where you wish to switch. In this example, we've chosen to switch on iframes. In MPEG-2, they'll come around a couple of times a second. The delay controls for the primary and the secondary paths have been set to 5 targets. That means that each of those memory buffers will insert a delay of 5 targets both in the primary and the secondary path. It's very useful to be able to change the delay independently for primary and secondary. One path might go by satellite, the other might be terrestrial microwave or fiber. In that case, the delivery time from one to the other is different, and these offsets for primary and secondary delay will let you accommodate that. With the switch point target identified and the primary and secondary delays set, we can look at the primary path and identify switching targets at iframes. If the secondary path is not aligned correctly to the primary, the buffer in the secondary path will slip time automatically to provide that alignment. Now, our packet-aligned switch will perform a clean switch from primary to secondary. The 4445 can switch cleanly from primary to secondary because the streams have been frequency corrected and they have been packet aligned so that the switch point takes place precisely at the beginning of an iframe. There's just one last thing to do. We need to reformat the output and restamp or replace the PCR, that's the program clock reference, and the PTS and DTS, presentation and display timestamps. They need to be replaced so that at the final output, those are consistent regardless of whether we're on the primary or the secondary output. That final step means that downstream equipment, an MPEG decoder, will see consistent clock references and display timestamps, regardless if the content is coming from the primary or the secondary side. That's the very definition of a clean switch, and the 4445 can be used in a variety of situations to provide that very important feature.